Hey friends, welcome to our YouTube channel Physics Zone. Today we are going to discuss the Newton's three laws of motion. Newton has given three laws of motion in which we study about the object's position, whether it is at rest or it is in motion, how it will behave when it is at rest and when it is in motion. Now let's discuss first law of motion. According to the first law of motion, when an object is at rest or in motion, until we apply an external force, it will not change its position of rest or motion. Means, when we have an object and we have not applied a force on it, it will continue to be in its position of rest. And when an object is in motion, and we have not applied any external force on it, it will continue in motion. This is the first law of motion. Means when we will not apply any external force on it, it is not going to change its position. Okay. Some students may think it in another way. Means let's have an object and a player kick it. This go on moving. After covering a distance, it stops here. It comes to rest. Some students can say that we have given it a force and it comes into motion, then why it stops after some time? I have said that first law never allows a body to change its position until we apply any external force on it. Here we have not applied any external force, but the body gets stopped after a time. Means it seems to that first law gone wrong, but no. First law is universal, it's not going to be wrong. Here an external force comes into play, that is force of friction. When an object is moving, it covers some distance and it stops. This stops because of the force of friction that comes into play when it is moving. It is in contact with the surface. The surface is applying a force of friction on this object that makes it stop after covering some distance. This is the Newton's first law. Got it? Now let's move to the next, second law of motion. In second law of motion, we deal with the momentum. We discuss how momentum is affected by the applied force or force is affected by the momentum. Here you may not aware of momentum, so let's first discuss what is momentum. In second law, momentum is the product of mass and velocity. When an object of mass m is moving with velocity v, its momentum will be mv. When an object of mass m moving with velocity v go on moving and stops here. It changes its velocity or stops. Anything maybe. Let's change its velocity v dash and mass is m. Let's clean it and do it with more space. We have an object, mass m, velocity v. It is moving, and while it come here, its velocity will be v dash mass m. Here its momentum was mv, and here mv dash. Its momentum got changed. Why this momentum change? We have applied an external force on it that changed its momentum. That external applied force is directly proportional to this change in momentum. This change in momentum can be written by dp by dt. Here we denote momentum by p. Momentum is denoted by p, and change in momentum is denoted by dp by dt. We have an object of mass m moving with velocity v, go on moving and change its velocity v dash. Here its momentum was mv, here its momentum is mv dash, then change in momentum will be mv dash minus mv. Now this change in momentum with respect to the time is denoted by dp by dt. So from here we can say that the applied force is directly proportional to dp by dt. This is the second law of motion. You may not be aware of dp by dt. I will discuss it later, but now you have to remember force is directly proportional to dp by dt. This is the second law of motion. Now let's move ahead and go to the third law. According to third law, every action and reaction are always equal and opposite. When we apply an force on this object will also apply an equal and opposite force on us. This is the Newton's third law. This can be better understood by considering an example. Let's have a wall. Here is a person who is pushing this wall with a force F. It is standing on a slippery surface with the surface with no friction. The person is pushing the wall with force F. Then the wall is also pushing the person backward. Due to the slippery surface, the person go back. This can be seen because of the third law of motion. The whole is exerting the equal and opposite force on the person that causes the person go behind. This is the third law. That every action and reaction are equal and opposite. Hence, we have discussed the three laws of motion. Now, let's discuss a little differentiation part. Differentiation is denoted by dp by dt. Differentiation means the change that is occurred in any physical quantity with respect to the time. Here in second law we have told you that force is directly proportional to the dp by dt, or we can say change in momentum with respect to the time. Here the change in momentum is denoted by dp and with respect to time dt. So dp by dt denotes the change in momentum with respect to the time. Hence, this was our lecture about the Newton's three laws of motion. Thank you for watching my video and have a nice day.